Yeah. Okay, so my today's topic is about assignment problem. Assignment problem is a special type of linear programming problem. It is a special type of linear programming problem. And it belongs to the module 3 of our syllabus. And although it is a special type of linear programming problem, but its solution doesn't require the application of simplex method or graphical method, because there are too many variables in this type of problems, and there will be too many equations for which if I try to apply the simplex process to the given problem, the given assignment problem, then that would be a tedious job. Theoretically, this can be done, but practically, we don't apply simplex method to solve this type of problem. But it is a special kind of linear programming problem. And how do we know that it is a special type of linear programming problem? It is by the fact when we look at its mathematical model, we get to know that this type of problem is indeed having all the features of LPP. So what is the mathematical model of this kind of problem? Let me first write that one. So to start with, you all copy it. I'm also copying this particular portion from a book. We considered some variables. Let xij be a variable defined by xij can take two types of values. Either the value of xij is 1. It happens when this happens if ith origin is assigned to jth destination, or you can write if ith person is assigned to jth job and is equal to 0 if ith person is not assigned to jth job. Okay, so this is a kind of problem where we consider a variable which we denote by xij. This type of variable can have only two values. One is 1 and another is 0. We consider the value of the variable to be 1 if we can assign the subscript I to subscript j. This subscript I may be an origin or maybe a person. This subscript j may be some sort of destination or maybe job. This subscript I may be a kind of machine, and that subscript j can also be considered to be a person or a job or whatever. I mean, there are two types of different two kinds of things which we are going to assign with one another. If we are able to assign them in some way or other, then we consider the value of the variable to be 1. And if we are not able to assign them, then the value of the variable is 0. So this is the nature of the variable xij in this particular case. What we need to optimize in this particular problem is the following. optimize capital Z. This optimize is a general word for minimize or maximize. You all know that. So this is the double summation over ij, double summation over ij, cij, xij, and here I am going to write I to run from the range of I is from 1 to n, and the range of j is from 1 to n. So what does it mean? It means that we are considering this type of variable, this type of function, c11 x1, c12 x12, and so on. Then we have c21 x21 plus c22 x22, and so on, plus and so on. Okay, cn1 xn, let me write it, cn1 xn n1 plus cn2 xn2, and
Sir,
so on.
এটা কি first page?
Yeah, this is the first page. I have not started discussing the problem yet. I'm just writing the mathematical problem to warm up the things. Okay, I know, I'm pretty sure that you are not warming up because the things looks very tedious. I mean, you are not probably not have got the idea about what am I supposed to do in this type of problem, but okay, forget it, you write, just write this model, because often it is in examination, we are asked about the model, we are asked about to write the model, or maybe in MCQ type of problems, you may be asked some MCQ type of questions, short questions from this model itself. Say, for example, you may be asked that in assignment problem, the variable, that means the decision variable, what are the possible values of that? So you may be given the option like one is the only possible value, 1 or 0 are the possible values, any value can be the values of the decision variables, and so on. So this type of problems can be asked from the mathematical model itself. Okay, so that's why I'm writing the mathematical model. Otherwise, in a classroom, actually offline classroom, I basically start with a problem. But okay, let me write the model first. So this is my objective function, and you see how huge this particular function is. So many variables are there: x11, x12, x21, 22, xn1, n2, n into n number of variables. How many variables are there in total? There are n square variables. N square variables are present. So it's huge. And therefore, it is not possible for any human being to do this particular problem using a simplex method. Anyways, so this is my objective function, subject to some restrictions, some constraints must be there. The constraints are summation over j goes from 1 to n xij. This should be equal to ai, which must be equal to 1. Forget about this symbol ai. I'm just writing it. It's just a number. Okay, so what am I doing over here? Here we are taking the sum row wise. I mean, I'll show you by a table. You will understand that. Let me finish writing this model first. That is one constraint. Another constraint that we have, summation I goes from 1 to n xij bj, that would be equal to 1. And here I runs from 1 to ... n. Here j runs from 1 to ... n. These are the constraints. And one extra constraint is there. It is summation I goes from 1 to n ai, and summation j goes from 1 to n bj. This must be equal to n. So this is the mathematical model. This is the mathematical model on which the assignment problem is based. Now you will understand a bit of this particular thing by if I draw the following table. So let me try to draw the table for you.
Hello, sir.
Yes, yes.
What is C?
Cost. C is cost, per unit contribution of the decision variables in the objective function, just like we do in the in linear programming problem. What does this coefficient represent? This coefficient represents the per unit contribution of the objective per unit contribution of the decision variables in the objective function. These are actually represented by C. C11, C12, dot C1n. Then we have C21, C22, dot C2n, dot, and lastly we have CN1, CN2, CNN. Okay, suppose on the left hand side of the table we have some persons. The name of the persons are as follows: P1, P2, these are the person names. Okay, and on the top of the table, suppose we have some jobs, which we denote by J1, J2, dot, JN. Now, you see the number of persons present in this particular table must be equal to the number of jobs in the table. So the assignment matrix, this is called the assignment matrix. This assignment matrix must always be a square matrix. This must always be a square matrix, is always a square matrix. Okay. Now, this is another kind of question which may be asked in the MCQ type of problems, that assignment matrix may be rectangular or may be square or both. So your answer must be that it should be a square matrix. Order of the persons, number of persons, and number of jobs involved must be same. There may be another question, MCQ type of questions, that may be asked, that how many variables are present in the assignment problem. The answer should be whether it is n factorial, n square, twice n, what? Then you will must say that there are n square number of variables, because n square boxes are there. Okay. Now, that's why this model, discussion of model, is actually very important. Now, what does this mean actually? Okay, so we have a box consisting of some costs. This may be costs, or this may be times also. Say for example, I'm writing T11, this is T21, this is TN1, like this. You can consider time here also in place of costs. Okay, I'm not writing everything because otherwise that would be clumsy. So instead of writing cost, and we can also consider this the time. So what does this mean? It means that if we assign somehow the person P1 to job J1, maybe I'm just saying it for the sake of your understanding, to make you understand the thing from pedagogical point of view. Suppose somehow I am assigning the person P1 to job J1, and he needs time T11 to complete the job. When the person P1 is assigned to job J2, he needs T12 time to complete the job. When the person P1 is assigned to job JN, he needs T1n time to finish the job. If these are costs, then probably, and suppose P1 is a machine, J1 is a job, so we can consider this to be, if job J1 is assigned to machine P1, cost involved is C11. If job J2 is assigned to machine P1, cost involved is C12. If job JN is assigned to machine P1, cost involved is C1n. Like this, we read the things like this. Question is, which person should be assigned to which particular job, so that, what is the question? Let me write the question first of all. Okay, the question is, in assignment problem, we need to find which person should be assigned to which job so that total cost or total time involved is minimum. That is the basic fundamental question that is asked in case of assignment problem. Table is huge, 100 persons are there, 100 jobs are there. Well, by visual inspection, it is not possible for us to find out because it will be, how what sort of difficulty will creep in if I try to do it by visual inspection. So we need to find out some mathematical tool by which we can very easily find out which persons should we select and which job should we select and assign them one-to-one so that total time or total cost involved is minimum. Now at this point you may ask me that you have written the word optimize over here. So optimize is basically a word which stands for minimum or maximum, but I am only giving you an example of time and cost. That there may be examples which are having the matrix elements as profits. If it is a profit matrix, then automatically it becomes a maximization type of problem. Okay, so the problem may be of maximization type, problem may be of minimization type, but we are going to, the basic fundamental question is that we are going to assign some persons to some jobs, or some machines to some jobs, or some cities to some roads, or any sort of assignment that you may think of, so that the objective function is maximized or minimized. So that is the objective of this particular problem. Now, problem is defined. Now, in solution, what we want to look at. Now, they are saying that basically in this kind of thing, what we need to do is if C11 is the cost involved, then corresponding decision variable for this particular cell would be X11, and for this cell, the decision variable would be X12. For this cell, the decision variable would be X1n. Similarly, for the cell C where cost is C21, the decision variable would be X21. Here the decision variable would be X22. Here the decision variable would be X2n. Similarly, Xn1 would be the decision variable in this cell, Xn2 would be the decision variable in this cell, and Xnn would be the decision variable in this cell. Assignment problem is, the mathematical model is saying us that try to fix these variables X11, X12, X21 in such a manner so that if I listen to me very carefully, the mathematical model is saying us that try to fix the values of these variables X11, X12, X and so on in such a manner so that if I add them row wise, if I add the things row wise, in this way, if I add the thing, the total must come to 1. For example, here it is written, J is running from 1 to n. So you see the J values are changing, 1 to n. Row is fixed, 1 is fixed. So in this case, we write X11 plus X12 plus ... plus X1n, that must sum to 1. Similarly, if I consider the row summation of the second row, that must also be equal to 1. If I consider the row summation of the third row, last row, that must also be equal to 1, which is actually being given to us by this particular constraint. And in the second constraint, it is also said that if I try to add the things column wise, if I try to add the thing in this particular manner, okay, that must sum also to equal to 1. If I try to add the thing column wise in this manner, that must be equal to 1. And if I try to add the thing column wise in this manner, that must be also equal to 1. that is being given by this particular constraint. Okay, now I am asking any one of you a simple question. Think and answer. Let me select a student. I don't know who is attending. I mean, I cannot select such person because I don't know who one of you is actually attending the class seriously. But whoever is giving me the reply, it's all okay for me. My question is, up till now, I have tried to make you understand the objective of the problem and how the constraints are designed. And you have seen that sum total of the rows must be equal to the one. Sum total of not the costs. Sum total of the values must be equal to one row wise for all rows, and sum total of the values must be equal to one column wise for all columns. How this is possible? What should be the values for x, these variables x1, xij's in this particular case, if this constraint needs to be satisfied? Suppose I am asking this particular question only for row 1. Then what would be the possible values for x11, x12, x1n? Can you tell me what would be the reply to my question? What would be the answer to my question? Have you understood my question? I'm fixing a row for you. It's a first row. Constraint, in the first row, the constraint is what? Row constraint is what? x11 plus x12 plus dot 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 plus x1n must be equal to 1. What will be the possible values for x11, x12, and x1n?
Hello, sir.
Yes, Akash, tell me.
Sir, in the row constraints, only one's value will be 1 and others will be 0.
Exactly. And if I consider stay unmuted, if I consider say, a particular column J2 for you, okay, and their the column constraint is 1. Sum of the values of all the decision variable is equal to 1. Then what will be the possible values for x12, x22, and xn2?
It will be the same, sir. One's
Same.
value will be 1
Exactly.
and then others will be 0.
Exactly. Now, suppose I'm fixing this particular say, row 1 and column 2 for you. Now, both the constraints, that means the row constraint, the sum total is 1, and the column constraint, that the sum total is 1, must be satisfied. Both the directions in plus sign kind of thing, both the directions must be satisfied. So in this particular case, you see that the only possibility is that we can fix the value of the variable x12 to be 1, which will satisfy the column constraints and which will satisfy the row constraint as well. And all the other values here in this particular row or in this particular column will be given the value 0. Okay, if I fix for row
Yes, sir.
1 and column 2, only possibility is x12 must be equal to 1. All the other variables should have the value 0, and all the other variables in the column J2 must be 0 other than x12. So when I'm assigning x12, when I'm writing x12 equal to 1, that means I am assigning person P1 to job J2. I'm assigning the person P1 to job J2, or I'm assigning job J2 to person P1, which is being signified by the value x12 equal to 1. It means one and only one person can be assigned to a job, or one and only one job can be assigned to a person. So if in a particular row or in a particular column, there is one and only one, if there is an assignment in a part, then in that particular row or in that particular column, there cannot be other assignments. And therefore, now you come back to this particular mathematical model of part. Therefore, it is written here that xij equal to 1 and or xij equal to 0. It is now probably now you can understand why it is written that xij equal to 1 when ith person is assigned to jth job, and xij equal to 0 when ith person is not assigned to jth job. Now see, person P1 is not assigned to job J1, so x11 is 0. Person P1 is not assigned to job Jn, so x1n is 0. But person P1 is assigned to job J2, and therefore x12 is equal to 1. So this is the reason for which the only possible values for the decision variables are either 1 or 0. And so I have made you understand why this particular thing has been written, why it is written that xij equals to 1 or 0. I have also tried to make you understand the meaning of the optimization of the term capital Z, which is either total profit or total cost or total time. You have understood from the table what do we mean by the constraint. What is the last point? What is this? This is saying that if your assignment is correct, if you have done the assignment correctly, then sum total of these ones must be equal to n, and sum total of these ones must be equal to n. So if I take the sum of these ones and sum of these ones, both must result in n. That means your assignment must be correct. Now you tell me I'm asking you one another question. You have already known that in this particular assignment problem there are n square number of variables. Can you tell me in this type of assignment problem what is the total number of assignments that we must expect? What is the total number of assignments in this particular problem? What is the answer to the given to this question? If we have an n by n table where n square variables are there, n square cost items are there, what is the possible what is the total number of assignment that we expect this particular problem must have? Is it, I'm giving you the option. Option number 1 is it n square? Option number 2, is it n? Option number 3, is it n factorial? Okay, let's stick to 3 options. Which one is correct? Total number of assignment.
Sir, total number of assignments will be same as the total number of variables.
That means you are saying n square.
Yes, sir.
But just now you have told me that x12 is, if x12 is 1, then in this particular cell other variable must be 0. And in this column other variables must be 0. But now you are saying the total number of assignment must be n square. When you are putting x11 equal to 0, that means you are not assigning anything.
So n factorial.
N hobe, sir, n hobe, n.
N factorial.
No, not n factorial. It should be n. Carefully observe. It is n. Because in every cell, in every row and in every column, there must be equal to one and only one assignment, not more than that. So in the first row, one assignment. In the second row, in this particular cell, if there is no assignment, you can assign over here. But if there is assignment, you cannot assign over here. Automatically, it will nullify this assignment. This particular assignment will nullify any assignment in the remaining cell of this column. This particular assignment will nullify any assignment in the remaining cell of this row. Okay, so this ones, the value 1 will be scattered throughout the table in some fashion. Okay, and when you are putting the value 0, that means you are not giving any assignment at all. You are not assigning person P1 to job J2, or you are not assigning, sorry, job J1, or you are not assigning person P1 to job Jn, and so on. Okay, because person P1 has got the responsibility of doing job J2. And in other words, one and only one person is supposed to do one and only one job. So it is a one-to-one kind of assignment. So therefore, the total number of assignment must be equal to the order of the matrix, that is n. So when you get this particular assignment, you will understand that, okay, my job is done and I have got my optimality. Understood? So this is all about
Yes, sir.
this is all about mathematical model. Now, as the time is running out, so I am stopping the share. Probably you have taken the screenshot by now. I am stopping the share of this particular screen, and I am going to show you the question that I shared in the WhatsApp group. You have the question with you
Sir,
already.
you have given two questions.
First one, you have already have the question with you. So many students are actually probably attending this class from a mobile phone. So for them, I am sharing the page once again so that they at least can copy the question, the matrix given in the question. And in the next session, I'm going to discuss the solution of the given matrix. So the question is this one. What is written? A department has 4 subordinates and 4 tasks are to be performed. The subordinates differ in efficiency and the tasks differ in their intrinsic difficulties. Okay. The estimate of time in man hours each man would take to perform each task is given by, now the task and the subordinate names are given row wise. The row headings are subordinate names. Task headings are given by Roman characters. And these values are actually the times in man hours. Okay, what am I supposed to do? How should the tasks be allotted to men so as to optimize the total man hours? Now, since it is talking about time, since man hour is a time, so it is the problem that I'll be discussing over here. Will it be a maximization type of problem or a minimization type of problem?
Sir, I guess minimization.
Yeah, it is a minimization type of problem because time is always supposed to be minimized. Okay, and therefore this assignment problem is a minimization type of problem, and we are actually going to assign subordinates to the tasks. But we keep in mind that only one subordinate is allowed to do only one task at a time, and vice versa. And since the order of the matrix is 4, total number of assignment here would be what would be the total number of assignment? 4. And how many items are there in this particular matrix? 16 items are there. And now what you can do, you can take I mean, if you have lots of amounts of time in your hand, leisure time, you can consider all the permutations and you know what would be the, I mean, how many permutations will be there. N factorial permutations will be there by which you can assign one particular person to another task, one subordinate to another task, and you are assigning and you are writing your outcome, that if I do the assignment in this particular manner, then this is the total time. If I do it in that way, this is the total time. If I do it in that way, that is the total time. And it is very time taking and nobody does that. So we need some concrete method. And if how many variables are there? 4 variables, 16 variables are there. So if I try to write the mathematical model, try to construct the mathematical model of this table and try to do it by try to do it by simplex method. Number of variable is 16 and number of equations will be 8, because you are going to take the row sum and there are 4 rows. You are going to consider the column sums and there will be 4 columns. So total number of equations will be 8. Total number of variables is 16, and you know what will be the size of the simplex table, and I cannot guess how many simplex table would be required to solve this particular problem. So there must be some other way to tackle this particular issue, and which would be discussed in the next session. So wait for that.
স্যার নেক্সট সেশন মিন্স আজকে হবে না স্যার?
হ্যাঁ, আজকে নেক্সট সেশন।
হ্যাঁ হ্যাঁ হ্যাঁ।
মানে আবার রিজয়েন করবো।
হ্যাঁ, রিজয়েন।